Okay, so one thing I'm going to start this video with is make sure you take a look in this week's work in the weekly, what is it, I think this is week 11 overview, about chapter 9 out of the Think Do book. I've got these notes, these cookbook exercises, and I also did these notes. And this stuff is graphing calculator syntax. I made this stuff for Oxbow, so I mean they have access to graphing calculators. You can do the same thing with Rossman Chance, though. I mean the hypotheses are worth looking at and using. So, but this question is about proportions. So let me zoom down to that so we can take a look at those formulas, those HO, not so much the formulas, but the setups for them. Okay, so when dealing with two proportions, what you're trying to say is that there's no difference. HO is there's no difference, right? They're equal. It's a statement of equality. So that's why I have that written this way. And then you got to decide is it left-tailed, right-tailed, or two-tailed. And sometimes it makes more sense to write it. So yeah, if there's no difference, the two proportions are the same. And if one's less than the other or one's greater than the other or they're not equal to it, that's fine too. Rossman Chance uses this notation. And if you look at to them where this question arose was this formula in chapter 9 right here. Somebody was wondering about that wonky symbol. Okay, see how it says uh, P1 minus P2? Well, that's not so much the hypotheses, but the test statistic. But see how it's related? Um, what this little funky symbol is if you're not saying so your hypothesis isn't that they're not equal, it's that they differ by some percentage. Okay, and most of the problems we're going to look at, this symbol is going to be zero. Okay. Um, and of course, that awful SE calculation. I encourage you, you've seen videos, you've seen my writing. Please use Rossman Chance. It's so much easier. And most of these problems are just not equal to, or you're just is that the difference is zero, right? So we don't have to worry about that. In fact, all the problems are this is zero. So we don't have to worry about it. Okay. I don't think I've ever seen a problem where they say they differ by a certain amount. So it's always either equal or not. So, all right. So hopefully that answers that question. And just to make sure, hey, I'm going to reiterate this because I want you to. I feel bad when people work through this darn formula. 'Cause what a pain. Okay, if you look at, we can go down and look at some of the other ones. Nope, not here, not chapter, not 10 yet. That's what you got to do during Thanksgiving break. Well, I'm doing this in the fall, so the fall is during Thanksgiving. Um, Here, let me click here again. Actually, let me click here and just go backwards. Okay. So do you see how all of these are just whether they're different or not? And so if I want to do this gun murders one, this is one of the ones that have Dr. Stevens, all the formula work in the back. But all we need to worry about is here. Let me get a piece of paper and copy this. If I go to Ross Chance, I'm gonna write down. Let's see. For Texas, it's 699 out of 1089, and for New York, it's 445 out of 774. And we're trying to test the claim that the proportion of murders committed by gun was significantly greater than Texas and in New York in 2011. Okay, so we're going to try to say P sub Texas is the same as P sub NYC, or that's HO. And then we're going to say for H1, we're going to say P sub Texas is greater than P sub NYC. Okay, here, maybe I'll click on my video here. I know I could scan it, I guess, but here, just a minute. Let me pause this. So I'm sorry I'm doing it this way. It's always weird when people do it for me, but it's easier. It is easier this time. So let me get a pointer going. So you see, there's the Texas P hat. There's the New York City P hat. What we're trying to test. And see, I didn't do the P1 minus P2. I did set them equal for HO, and it doesn't matter. It's just right to do it the other way. But there's no difference. You're trying to say there's no difference for that funky little symbol is zero. We don't need to worry about it. Okay, so there's that one. That's my HO, and then this is the claim, right? This H1's the claim in this case, because we're testing the claim that the proportion of gun murders in Texas is greater than the proportion of gun murders in New York City. So here, pause this. I'll go back to Rossmann-Chance. Okay, so I went out to Rossmann-Chance. You got to make sure you select two proportions. And for Texas, because that was group one, that was, let's see, they want N first, don't they? So 1089, and there were 699 murders caused by guns, and or however we word it, and then 774 and 445. Calculate it, run a significance test, and we're going to say one is bigger than two, and there we go. There's the test statistic. There's the p-value. The p-value is small at the 5% level and at the 1% level. So in either case, we're going to reject HO. Okay, so you notice much easier. You don't have to do any calculation. Please use this. Want two proportions, two means, and then of course, if you want to do the matched pairs, the first section, find the differences and just run a one mean test because you're doing the one mean of the differences, okay? And let's see, can I pull this up? So I might back here in this handout with a difference. See, there's the mean difference. That's where we're dealing with the differences. Notice it's a one-tailed test. I mean, a one sample test with the differences, and then the independent means is this setup, and that's going to be two means on Rossmann-Chance. And of course, if you want to use your graphic calculator, it's stat test 4, and if the confidence interval is the stat test 0, you can see that if you have a graphic calculator, want to use that. Okay, and then I mean, if you want to get some practice with this, go ahead, make a post in the discussion forum. And I'm going to ask you questions that aren't like the Think Do book in the last exam. So you should get some practice with other kinds of problems. Okay, and no, always the same. Check the conditions. Make sure you're running the right test. Okay, I guess I don't want to make this video longer. Just make sure I'll end it. The number one mistake people make on exam 1 or even on the next quiz is they run a paired difference as a two independent sample test, two independent populations. That's wrong. I mean, you got to check the conditions if they're dependent samples, the same person, the same family, before and after, that's a paired difference. Find the differences. Any other kind of means, it's safe to use two independent means. Okay. Long enough video.